Welcome to Prompt Society. Today we're taking a deep dive into something, well, pretty fundamental. How artificial intelligence is reshaping the very bedrock of software development. It really feels like more than just a new tool, doesn't it? It's like a redefinition of how we build, who can build, maybe even what we value as work.
That's exactly right. It's a huge shift. And our mission today really is to distill insights from some of the sharpest minds thinking about this. We're talking about folks like Andrej Karpathy, ex-AI director at Tesla, Andrew Ng from AI Fund and Coursera, and Sean Grove over at OpenAI. They've shared some incredibly perceptive views on where all this might be headed.
Yeah, prepare for some genuinely thought-provoking stuff because what we're seeing, it isn't just an incremental update. This is like a fundamental reimagining of software itself. And maybe the best place to start is with Andrej Karpathy's observation, this idea that software is changing again.
Hmm.
He suggests software hasn't changed this fundamentally in, 70 years, but has twice, just in the last few. That's kind of wild.
It is a powerful point. He breaks this whole evolution down into three distinct eras, each one representing a different way we basically tell computers what to do. So first up is Software 1.0. This is the traditional stuff, the code you write explicitly, line by line, defining every single instruction. Think of it like a super detailed recipe. Every ingredient, every measurement, every single step spelled out. Tesla's autopilot, for example, it started with a lot of C++ code, very much in this traditional paradigm.
Right, the classic coding most of us think of.
Yeah.
But then came this completely new way of thinking.
Exactly. Next came Software 2.0. And here, you're not writing direct instructions anymore. You're working with neural networks and their weights. So instead of coding line by line, you're tuning these massive data sets, running optimizers. It's less about direct coding and more about shaping the data itself. Kind of like a master chef adjusting ingredients and methods, tasting, refining, until it's just right, not writing out molecular instructions beforehand.
And Karpathy actually saw this Software 2.0 stack literally eating the old code. He mentioned, I think, that at Tesla, a whole bunch of C++ code just got deleted as neural nets took over functions like stitching camera feeds together.
Yeah, a very clear demonstration. It wasn't just adding to it, it was displacing it, one paradigm kind of overcoming the other. And now we've entered Software 3.0. This newest paradigm, it's all centered around large language models, or LLMs. Here, your programs are basically just prompts, written in natural human language, like English. And you use these prompts to program the LLM.
Wow, that's an incredible leap from super detailed code to just talking to the computer. What does that fundamental shift mean for who can even be a programmer now?
Well, it's truly transformative, isn't it? With LLMs, English becomes the programming language. Imagine just telling a really capable assistant, in plain English, summarize this article for me, and it just does it. Instead of needing to write some complex script, it massively democratizes access. People without traditional coding skills can suddenly command complex computations.
So for us, for anyone in tech, what's the big takeaway from these three eras?
Karpathy really emphasizes that it's now vital to be fluent in all three. It's not just about knowing different coding languages. It's about understanding that the most valuable folks will be those who can fluidly pick the right tool for the right job across this whole spectrum. Traditional, data-driven, AI-driven. It's about blending them strategically, not just sticking to one lane.
Okay, that breakdown of Software 1.0, 2.0, 3.0 really sets the stage. It helps understand what these LLMs are. But how do they fit into the bigger tech ecosystem? Andrew Ng compared AI to electricity, which is pretty fundamental.
Yeah, and Karpathy expands on that analogy, and it's quite insightful. LLMs definitely have properties of utilities, no doubt. You've got companies like OpenAI, Anthropic.
Yeah.
They're building out the grid, right?
Yeah.
Training these huge models. That's like building massive power stations, enormous capital expenditure, high capex. Then they serve up that intelligence over APIs.
Yeah.
Application programming interfaces, the standard ways programs talk. And it's metered access. You pay per million tokens, just like you pay for electricity per kilowatt hour. And we demand low latency, high uptime, consistent quality, just like we do with our power.
But it goes beyond just being a utility, doesn't it? He used another analogy that felt even more resonant.
Absolutely. Yeah, while they share crates with semiconductor fabs also needing huge investment, Karpathy's most compelling analogy is LLMs as operating systems.
Operating systems like Windows or Mac OS. That's a big comparison. How does that work?
It is big, but it makes a surprising amount of sense when you break it down. Think of the LLM itself as the CPU, the brain, and its context window, that limited amount of info it holds in active memory that's like its RAM. The LLM orchestrates this memory and compute to solve problems. And just like we have closed source OSs like Windows, Mac OS, and open source ones like Linux, we're seeing a similar ecosystem emerge for LLMs. Things like the Llama ecosystem could potentially become the Linux of LLMs.
So in that sense, are we kind of in the 1960s era of computing with LLMs, like the early mainframe days?
Precisely. That's a great way to put it. LLM compute is still super expensive, very centralized in the cloud, so we're often thin clients interacting over a network, much like early computer users accessing those big mainframes. And when you talk to an LLM directly, just typing text, it's basically like using an old school terminal.
No fancy graphical user interface, no GUI yet for that raw interaction.
Exactly, not for the direct LLM interface itself.
What feels really unique this time, though, is how instantly these powerful tools have spread. It feels different from past tech revolutions.
Oh, it's completely unprecedented. Unlike electricity or early computers, which usually started with governments, big corporations, and then slowly trickled down, LLMs got instantly beamed down to billions of people overnight. It's like ChatGPT just appeared on everyone's computer immediately. People started using it for, helping boil an egg. Meanwhile, large organizations are still scrambling to figure out integration. It's totally backwards from how tech usually diffuses, speaks volumes about their accessibility.
Okay, so these LLMs are powerful, almost like a new digital brain. But Karpathy also calls them stochastic simulations of people with an emergent kind of human-like psychology. What exactly does stochastic mean there, and what are these human-like traits?
Right. Stochastic basically means they act human-like, but with an element of randomness or probability involved. Not perfectly predictable. They're trained on vast amounts of human text, so they pick up our patterns or ways of thinking. But it leads to this unique emergent psychology. They have these incredible superpowers, for instance. Encyclopedic knowledge, memory far beyond any single human. Karpathy compared it to the character Rain Man. Right, almost perfect recall. LLMs can remember crazy complex data strings easily.
But then he immediately points out these peculiar cognitive deficits. It sounds like a paradox superpowers and strange weaknesses side by side. Can you paint a clearer picture? Like, what do those deficits look like day to day?
Absolutely. So they can hallucinate, just make stuff up confidently. And they display jagged intelligence, meaning they can be superhuman at one thing, writing complex code, translating languages, but then make incredibly simple mistakes no human would, like insisting 9.11 is greater than 9.9, or saying strawberry has two R's. It's like this super genius who occasionally struggles with, like, basic arithmetic or spelling. Good reminder they aren't perfect.
Yeah, definitely. And there's also something he calls anterograde amnesia, which sounds pretty significant.
It is, metaphorically, for an LLM. Unlike a human colleague who learns, consolidates knowledge over time, maybe even through sleep, LLMs don't natively do that. Their context window is their working memory, and it essentially gets wiped clean for each new interaction unless you feed that context back in. He suggests watching movies like Memento or 50 First Dates to really get at characters whose memory resets constantly. This also makes them quite gullible, susceptible to prompt injection where bad instructions hijack them, or they might accidentally leak data if you're not careful.
Wow, that memento analogy really lands. So for us as users, that means we just can't expect the LLM to remember our chat from yesterday unless we explicitly give it that history each time.
Precisely. That's a key limitation to keep in mind. And this leads us directly to the concept of partial autonomy apps. Instead of talking directly to the raw LLM operating system via text, we use specialized apps like Cursor for coding or Perplexity for research. These apps handle the tricky stuff, managing context, orchestrating multiple LLM calls behind the scenes, and crucially, they provide application-specific GUIs.
GUIs, graphical user interfaces. Why is that so important here? Since LLMs work on text.
Exactly, because text is actually quite effortful to read and interpret, especially long outputs or complex code changes. A GUI with visual stuff like red and green changes in a code diff, showing additions and deletions clearly. It leverages our natural computer vision GPU in our head, as Karpathy puts it. It just makes auditing the AI's work much faster, much more intuitive, even more enjoyable for us humans. You want to click accept, not type out a paragraph, right?
Totally see it. The visual feedback loop is critical. And these partial autonomy apps also bring in this fascinating idea. An autonomy slider, right?
Yes. It's a brilliant concept. It puts the human firmly in control. You, the user, get to decide how much work the AI does. From simple auto-completion in your editor, all the way up to full agentic actions across an entire project. Karpathy drew parallels to Tesla's autopilot the car doing more and more on its own, and even the Iron Man suit. Sometimes it's just an augmentation Tony Stark controls, enhancing his own abilities. Other times it's a highly autonomous agent flying solo. The key is the human controls that slider, especially with these powerful but sometimes fallible systems like LLMs.
Yeah, that definitely speaks to that human AI cooperation loop. AI generates, we verify. It feels like keeping the AI on a leash with smaller concrete changes is the way to move fast without, breaking everything. Verify small chunks.
Exactly right. That incremental human-in-the-loop verification, it's crucial for both speed and safety.
Okay, this idea of human AI cooperation, building with speed, that brings us nicely to Andrew Ng's perspective. He really focuses on how this tech changes the pace of innovation, especially for startups. Execution speed, he says, is a huge predictor of success.
He really hammers home the importance of concrete ideas. Vague stuff like using AI to optimize healthcare assets. It just leads to slow execution. Engineers don't know what to build, endless meetings, analysis paralysis. But a concrete idea like software to let hospitals book MRI machine slots online to boost usage and cut wait times that you can build and test fast. You quickly find out if it's a good idea or not. Invaluable for a startup.
And this translates directly into massive increases in engineering speed.
Oh, it's astonishing. AI coding assistants are making engineers like 10x faster, sometimes more, for quick prototypes. And even for production code, maybe 30, 50% faster. This changes so many long-held assumptions. Things that used to be one-way doors, big architectural decisions hard to reverse, like picking a tech stack. They're becoming two-way doors because the cost of just rebuilding the entire code base has plummeted. The code itself, the artifact, is becoming less valuable because it's just so much easier to generate and even throw away. The value shifting elsewhere.
And this impacts more than just the engineers, doesn't it? Sounds like everyone needs to rethink their role a bit.
Absolutely. Andrew Ng has this, what he calls a controversial opinion, that everyone in basically every job role should learn to code. Not in the traditional sense, not Python or Java necessarily, but learn how to steer AI to do the coding for them. It empowers everyone. Think about how learning, say, COBOL made programming easier for more business folks decades ago. AI assistants are doing that now, but for a much wider audience. The critical skill, really, is telling a computer exactly what you want it to do, very precisely, like someone with deep art history knowledge. They can prompt Midjourney to generate specific, amazing art reflecting historical styles. Someone without that knowledge just gets, pretty pictures of robots.
Right. So if engineering gets faster and more people can effectively code via prompts, what's the new bottleneck for startups?
Product management, getting that user feedback, deciding what features to build next. The PM to engineer ratio is shifting dramatically. Eng mentioned one team even proposed having twice as many product managers as engineers.
No.
Yeah, it's a huge shift because the ideas and validation become the rate limiter, not the raw execution speed.
Okay, this all ties in so well with Sean Grove's point about the new code. He has this really provocative take on what the most valuable professional artifact actually is.
He argues, pretty convincingly, I think, that communication is the most valuable artifact. Makes up maybe 80–90% of the value we actually produce, not the code itself. Think about your work, talking to users, distilling challenges, planning, sharing designs, testing. All of that is structured communication.
This really resonates with that idea of vibe coding, doesn't it?
Yeah.
Just telling the AI what you want, the vibe, and it produces code. It feels good.
Exactly. Vibe coding feels good because it is fundamentally about communicating your intent, your desired outcome, and letting the AI handle the grunt work. But here's the critical flaw he points out. We usually throw away the prompt our communication and just keep the generated code. That's like shredding your source code and only versioning the compiled binary. It's crazy when you think about it. You lose the original intent, the why behind the code.
Okay, so what's the fix? How do we preserve that incredibly valuable communication?
The solution, he argues, is written specifications. A specification is the source artifact. It's the thing that aligns humans and models on the shared goals. It's the living document you discuss, debate, sync up on. OpenAI's own model spec, apparently, is just a collection of markdown files. Human-readable, versioned, accessible to everyone, engineers, legal, everyone. And these specifications can even be executable in a sense, providing success criteria that models can actually be tested against, ensuring they behave as intended.
Huh. It almost sounds like he's suggesting lawmakers are becoming programmers, or that policy documents are the new code.
He makes this powerful analogy, actually, to the U.S. Constitution. He calls it a national model specification. It's got written policy, amendments, and judicial review as a kind of grading mechanism. How well does a situation align with the spec, the policy? Programmers align silicon with code specs, PMs align teams with product specs, lawmakers align humans with legal specs. Now, with AI, everyone writing a prompt is effectively a spec author. You're aligning an AI model with your intentions, your values. And that, he argues, is how we ship faster and safer, keeping that clarity of intent front and center.
Okay, so much excitement. But inevitably, there's also a lot of hype, maybe even some fear, around AI. Andrew Ng tackled some of this head on. What kind of narratives does he suggest we filter out?
Yeah, he's pretty clear on filtering out narratives he sees mainly as hype, often amplified for PR, maybe fundraising. Things like AI definitely leading to human extinction, or wiping out thousands of startups overnight, or needing only nuclear power plants for compute. He emphasizes these are often distortions, designed perhaps to make certain players look more powerful or create unnecessary panic.
Right. And instead of focusing solely on AI safety, he prefers a different term.
He prefers responsible AI. His view is that safety is really a function of how we apply the technology, not the technology itself being inherently safe or unsafe. Think of an electric motor, right? It can power a beneficial EV, or it could power a harmful smart bomb. The motor itself isn't the issue, it's the application.
Makes sense. He also mentioned a crucial fight kind of happening right now for the future of AI.
Yes, he highlighted the danger of potential gatekeepers. Folks may be using hype to push for regulations that could stifle innovation, especially for open source AI. Some businesses might want to control the foundational models, limiting who can fine-tune them or build on top of them. He argues that protecting open source AI is vital to ensure broad access, keep innovation flowing, and prevent power from getting too centralized in just a few hands. It's a really important battle for accessibility.
So looking ahead, as AI keeps advancing, what's the most important thing for us to focus on, according to...
He really believes that, while, sure, some people will build the tools, the most powerful people in the future, the ones driving the biggest impact, will be those who know how to use these AI tools effectively to make computers do exactly what they want. It's about commanding the intelligence, leveraging it, rather than just building the underlying engine. It empowers everyone.
Wow, what an incredible deep dive. We've covered so much ground on this changing world of software and AI. We've seen programming evolve from direct code through Software 2.0 all the way to prompts in Software 3.0. We've explored how LLMs are kind of like a new operating system and how these partial autonomy apps with that cool autonomy slider are speeding up development. It seems abundantly clear that communication expressed through clear, precise specifications is really becoming the new, invaluable skill in this age of AI.
Absolutely. And as Andrew Ng reminds us, amidst all the noise and hype, the real power lies in understanding how to apply these tools responsibly, effectively, making sure we continue to innovate in ways that empower everyone, not just a select few.
So here's a thought to leave you with. Given that experts like Eng suggest knowing how to use AI will be more crucial than building the tools, and that vibe coding in natural language basically makes everyone a programmer, how do you think traditional coding education needs to adapt for this future? Let us know your thoughts in the comments. See you next time on Prompt Society. Take care and keep prompting.